Hello, 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 welcome, welcome, welcome. Let's get started. So what I did this morning is not a lot. I actually only increased the overall fidelity of the mesh. So as you can see, we have like way more triangles and everything. So we should be able to make a smoother object. But yeah, it's still kind of busted with where we are generating it. I thought I have potentially fixed it, but probably I haven't. So that I think is fine. But I think this voxel index is wrong. Probably. Because I think it's voxel chord times 32. Because we changed it a little bit. Or is it? So it's that plus the grid size, which is 32. So it should be voxel chord, voxel chord, voxel chord. And the grid size, we will do UVEC3 grid size is for now UVEC3 32 32 32. And then I think that should be that. And the cell size we need to adjust as well. And then here, that edit voxel is as well this. Edit voxel chord, edit voxel chord, edit voxel chord. That should be the trick here. That can be grid size X, grid size Y, grid size Z. And I think we need to change the cell size that we push here. Because that one should be 1 now. If I'm not mistaken. Let's see where we get with that. We get a crash. 144. 144. Why? What? Syntax error. Unexpected equal in 144. Oh, fair. Oh, there it is. Is the grid? Yeah, the radius is probably too big. 5, or let's do 2. Let's do 5. Let's bring over the point light so that we have a little bit of light here. Oh, there it is. But it's not quite matching where I would want it to be. It's not quite correct yet. Oh wait, maybe it's because of that. Oh yeah, it is. Yeah, okay. Because now it's correct. Yeah, okay. All of that makes sense. We need to increase our... probably our render... thing. Because I don't think we run out of mesh vertices. We probably just don't render everything. So let's do 100 times 10 times 100 should be the thing that we generate, right? Or it's actually 100 times 100. No, let's do 10. I'm confident that that should be enough. I say that now, but let's see. I mean, it's a million triangles or something like that. That should be more than enough. Huh. It's not quite doing how I would want it to work, but... Huh. That's a bit weird. Are we not doing a static mesh less equal? Some beta graph serializer less or equal? Should be fine. Right? I think so. But it doesn't look too fine. It looks a little bit busted. But we might be able to capture that. But I mean, that's already pretty good, not gonna lie. So how come that's the thing, right? So let's look at the mesh first. So the mesh looks fine. I think. Yeah, the mesh looks fine. Let's look at the depth texture. Do we have a depth texture attached here? Yes, we do. But somehow it's empty? How come it's empty? Oh, is it because of that? That makes sense. Oh god. Okay, so that, and then we go to static. God damn it. Why do you not want to work, huh? We just draw. Why is it not working anymore? Okay, whatever. Visual Studio stopped doing what I want. So we need the indirect draw for sure. What happened to my camera? Alright. So we need to disregard that and basically do the same draw core that we do in the mesh. Oh, there's a bag there. Never mind. So that should hopefully work better. Because now we should have a depth texture again. Yeah, that looks better. I mean, yeah, the light is not perfect by any means on the corners and stuff like that. But we can edit. And I mean, it's pretty fast. Nice. Okay, and then we broke again. How many vertices is that it breaks? I mean, I guess we ran out of vertex buffer then in that case. Fascinating. That would be interesting to check, I guess. So we basically do a render doc here. Now we fill it a little bit with like data, right? Oh. Okay. So how many vertices does that have? Mesh. Well, actually pipe spline. Mesh vertices count. Oh, we are just above 100,000. So actually, I don't know, let's make... I don't know what the reasonable amount is, to be honest. Guess we don't really want an upper limit per se, but I mean we have to have one. So let's make 500. I don't know. What sounds like a good value? Maybe one shifted by 19. Let's do that. It's 524,000, right? Let's see if that breaks at any point, if we fill that. We could as well output like a warning, right, that we are not fitting anymore. How did that connect there? I mean, I think we cannot really break it anymore with that, maybe? I mean, definitely we can break it eventually. If we just fill it good enough, but... Let's actually look at, if we fill that now, how many vertices we get here. Actually, the volumetric code is not entirely correct currently, but we will be able to fix that in a second. Because we are missing like one case that might break. Let's take one sample here. Let's see, how long is that? I mean, the generate is actually quite low in terms of performance, which is good, I guess. We might be able to increase the resolution even more. But for that we would need to give it a smarter algorithm than just a uniform grid. Otherwise we are running out of memory. Just a bigger problem. I mean, that's pretty reasonable. 200, like 160,000. I mean, again, the mesh is overly tessellated probably. And yeah, there is like issues here, which is kind of funny, but we can look at that eventually. And it might be that it's because of what is currently broken, but I'm not sure. Okay, I mean that's pretty nice. Let's fix the algorithm. By actually, when we generate our volume mesh, what we want to do is here we are missing the 3-point case. If out components, oh, that might actually be the reason why it's broken. I.vertex count equals 3, then we do something specific, else we do that. And if we are 3, so if we are 3, then where is it? Yeah, then we just add the vertex like that, right? Yeah. So basically then we just do this for 3 vertices. And we add our vertices. And we add them in the correct order, so 0, 2, 1. And then there is another thing that we need to add, but that should already help quite a bit. And might actually fix the weird side effect that we had. Actually it doesn't. That's weird. Somehow generates a broken mesh sometimes. That's something we can definitely, or we have to look at for sure. It looks like it actually is like some sort of none, maybe? Maybe. Yeah, that looks kinda like none. That's fascinating. But I mean, hey, we have live editing already better than I would have thought. It's just that we don't really want to hit the back face, which is kind of something that we currently don't support. Actually, hold on, that is not correct where it put the sphere now. It's not where I would have wanted it to be. Is that maybe still wrong? Does it need to be like that, maybe? Hmm. Ah, that still doesn't really work. Because I cannot really put something in the middle. It always blocks before. How come that's the thing? Voxel cord. Sphere center. Hmm. Yeah, probably it's still not entirely correct where we hit with the ray. It's better, but it's not 100% correct. I mean, that should be fine, I think. That should be good as well. Then the sphere is word position, sphere center, radius. Yeah, that looks fine. This might be an issue right here with the gradient, so that might be where the artifact is coming in as well. Potentially. But yeah, I would want to have a nice hit actually. But somehow it doesn't work. But I mean, that one, for example, is like 1 and positive. And then here on 1 it's 0. And then it's -1 above. So minus is air. So minus is air, exactly. So if we hit air, we don't want to have a hit. So only if we do that, we register the hit. Is the cell size maybe wrong? Wait, that might be. Did I maybe not see an editor? Did I change? No, I did change the cell size. Because then that should be just that, right? And then our voxel grid is fine like that. We shouldn't be so far off. Fascinating. Don't think we should be that far off. But somehow it hits here instead of where I clicked. Because it should have... It really just does it on the first. Why does it do that though? How can I debug that best? Because I can't really do a capture when I mean, I guess I could try to implement that maybe. Add like render dog to the... And then that is even more bizarre, right? Oh. It's when we are merging. Okay, that might be something that's still missing potentially from the algorithm then. That's quite possible. No. God damn it. Okay, I mean, maybe we add more shapes and we try to fix like the edge cases, right? But overall it's quite nice, and then we need to add like the... We definitely need to add the possibility to do that with the indirect draw, because that's definitely broken as well, that we currently do it manually. Let's fix all of them by making them disappear. I mean, good enough. Let's actually... So there's a couple of things that we can do now. As I said, we have to fix the algorithm because there's a small issue there for sure. How much GPU does that? It can't be too much, right? Yeah, it's pretty reasonable. Alright. Let me quickly go here. Thank you. And no thank you. We don't need that offer. Alright, so let's do a couple of things. So first, let's add the remaining puzzle piece for the generation. Because that definitely is something that... So first of all, I would probably want to do that. If we... Are we actually already normalize it? Never mind. Why is it a VEC 4? I'm not sure why we did that, but okay. And why it's a... Questions over questions. Not sure why it's a VEC 4, not sure anymore. Why I did it as a VEC 4 here. I think on the CPU it's not a VEC 4. Maybe I did it... Nah, I don't actually know why I did it. I don't think it is a VEC 4 in here. No, it's not. It's just a VEC 3, yeah. A little bit of wasted memory, which we probably should get rid of. Because it adds up over all the voxel stuff we have, right? So it's definitely something. But here the ambiguous case, that one I wanted to add. Because that one we currently don't handle. So we basically do resolve ambiguous case here. And I think we have that already. Or not. Okay, maybe not. We can do bool resolve ambiguous case. We take a phase index. We take the case, which is a uint margin squares case. And then we take the VEC 4, well, VEC 3 corners and VEC 4 Hermite data. And then we take the in outline segments. Oh, god damn it. Wrong one. We might as well just output maybe. Yeah, let's see. And then we go here and we basically copy that. It doesn't really matter too much. I guess we could output 2 vertices or something like that. I don't know. Let's see. So that's a uint, I think, because it's the same as we have down here, probably. Yeah. And I do think we have that somewhere. So ms table. So it's like that, like that, like that, like that. And we probably have to do that somewhere below here. Because we need the other functions to be there. And then, yeah, we have vertex that, vertex that. And then we have calculate 0 crossings. which we do here as well. So all of that should be fine. Then we need that thing. And then if we are ambiguous, we take our ambiguous case, we do the same again. And then we probably have that, right? Yeah, we do. And then we calculate the intersection. And then basically we do here a line segment with 3 points. And we go from edge 0, vertex 0 to intersection to edge 2, vertex. Now we go from cube edge 0 to cube edge A, cube edge B. And that should do that. Then we do the similar thing here. Well, we only do 2 then here. And we go from that to that. And from cube edge 0 to cube blah. Yes. Then we do the similar thing for this one. Where we go from edge 1 to edge 1 and then intersection 2. And cube edge 1, cube edge 1. So that's that. Then we need to resolve face sharp feature, which is this one. Which we can as well take from here. Why do we have 2? Oh, we have 2. Okay. So we probably need another helper function. Onyx, well, uint x y vec2 and we probably don't want to do that. We just say edge crossing that. Oh, that should do that trick. And then that is another vec2. And then this is position. It's a vertex, right? So probably we want an out vertex here. Out intersection. The vertex has a position and a normal, yeah. And yeah, this normal is kind of wrong. We probably have to interpolate the normal or something like that. So that's vertex and that's vertex, perfect. That might, I mean, we probably made a mistake somewhere. Well, we need the other one, so bool, resolve face sharp feature, where we take a vec2. So that's a vec2 edge crossing from vec2. Out vertex. Oh, or out vec2 maybe. Yeah, we don't have that min and max cell boundaries currently. So let's not do that for now. I don't know. We should definitely re-add that. I'm not even sure how we will test that nicely if that actually works. Because that ambiguous case is a little bit hard to test. Compute intersection. Oh, beautiful, we have that point here. Back 2 probably. Compute intersection. Back, oh god. Back 2. Back 2. Back 2 and back 2. Float. Is it even, wait, is it even used? No, right, so let's actually remove any of that crap. So all of that is garbage anyways. That's the correct part, right? I think that's all we need, because the other one was just garbage data from old stuff. So vec 2. We can't probably make that actually const. Then we have here vec 2 projected. Oh, that's actually a float, sorry, float. Dot. And then that is as well dot. That should do it. And yeah, we have the min and max bounds, I think, here, right? Or do we not have them? Yeah, we do. We can pass them in. Min, max. We probably want that actually before the in out. So vec 2 min bounds, vec 2 max bounds. And then let's push that forward to here, right? And then from here we push it forward to here. And then here we can get rid of that again. And then we have here min bounds, x, max bounds, x. I mean, we could probably clamp it, right? Wouldn't that be better? I mean, that is just a clamp, but whatever. Oh, why? Not X. Min, max, max, min. Perfect, and here at the end, before that, out intersection. Oh yeah, that's fine. And then here, min bounds, max bounds, and that. And then wherever we call that one, Min bounds, max bounds. And then wherever we call that one, min bounds, max bounds. And here as well, resolve face sharp feature, right? Did we not handle that here as well? Yeah, exactly. So we handled that, and that one is an out intersection vertex. Face index. From to min max and out intersection. Okay. Min bounds, max bounds, and intersection vertex. Then this is like 3 vertices. Where we go from edge 0 to edge 2. No. To like to the intersection and then to the 2. Then still cube edge 0, cube edge 3, that's fine. And then this one doesn't need anything, right? Because that one we already called correctly. Yes. And then here we called that one as well correct already. I think we don't have that yet. Yeah. Oh god, that is a pain. That one is a pain to port. Because we need the separating exit theorem and everything. Oh my god. I mean, it's not the end of the world. Oh, we don't need the case here? Why did I... Why did I put the case then there? I guess it's an oversight. So yeah, we basically take that. Where we... yeah, okay. Oh, that will be a beautiful one. So that's a U and face index. Then we don't take that one. We take a vec 2, vec 2, vec 2, and vec 2. And we probably need the bounds as well, but let's see. I mean, that will not compile again for years, that shader, because we have so many new changes. Why did we save that in a... Why are we saving that in a... Ah, because I think I wanted it for debug reasons. Vec 2. Wait, what? Oh, that's a vertex. Why do we have that multiple times? There was something that I thought about that, but I'm not quite sure anymore what. Why is... I am not quite sure anymore why we did that. And I don't think I need to have that. So let's leave those out for now. I think they are kind of useless. Vec 2, vec 2, vec 2, vec 2. And then this one is normalize. Okay. And then we basically do that. We resolve that face sharp feature here. Where we give it the positions and we get out a vec2 intersection, yes. And we probably need the bounds here, yes. So we need vec2 min bounds, vec2 max bounds. Min bounds, max bounds. Like that. And that should give us that. And now we know if we are an ambiguity or not. Oh, that's why we did it, or what? I mean, maybe there was more to that. Maybe there was some logic to that. So vec3. Hold on. Yeah, okay. So that is probably a vec3. Vec3. Well, actually a vertex maybe even. I think we need X, Y, Z here because, yeah, it's like a vec4. Okay, and then this one. Okay, doesn't work. Cool. Thank you for absolutely nothing. Alright. And then we do a set 2 is overlapping. But are we even using that? Hold on, how we... Wait. No, we are not, right? Let's kill that actually. So basically we do a couple of set 2D checks. And then let's put that up here. We will probably move a couple of those out into like a helper header. But yeah, we're not using those, so they are completely obsolete and completely useless. Yeah. I think they were just for debug reasons, as I already said. Which one are we? We have two overloads here. One that takes 1, 2, 3, 4, 5. And then one that takes 1, 2, 3, 4, 5, 6. Are we using those? One. So that's line. Oh, that one takes the 6, okay. Oh, okay. I think it actually makes kind of sense. So we take one that is basically like 6 vec2s. And then one that takes 5 vec2s. Which is basically one triangle and a line. And the other one is 2 triangles. So basically it's triangle, like, whatever, like 2 triangle v0 vec2 p1 vec2 p2 and then vec2 line p1 or like p0 line p1 and then the other one is basically triangle 1 1 1. Kinda. Is that? Oh, so many helpers. God damn it. Are we using those edge normals? Oh yeah, we do. Okay. Fascinating. Man, that is like years ago. I wrote that part of the engine. Like, I mean, engine. That was in the Unreal plugin. I wrote that 2020 or something like that. It's like ages ago. I didn't even know that I have that. So yeah, we would need to translate that. I will probably do that now, but I will take a quick break, get another coffee maybe, and then we will continue. Be right back. Alright. So, let's actually do that right away. Create a new folder here. Sat.age. Includes math. Sat.age. Because we want to replicate a couple of functions, which kinda is a little bit problematic, right? So here we basically get like void get triangle edge normals. We give it 3 points and we get out a vec2 edge normals. Was it like that, or was the out before? See, I can't remember that. No, it's at the end. Okay. Yeah. Well, that's that. And we basically do that. Well, kinda. Vec2 edge 0 like that, vec2 like that, vec2. So triangle P0, triangle P0, triangle P1, P1, triangle P2, P2. No, what? No. P2, P2. Then edge normal at 0. Edge normals at 1, edge normals at 2. And get perpendicular clockwise is just that, right? So M components 1 and M components 0, so basically vec2 of edge 0 y, edge 0 x, and then we flip the x. Edge 1, edge 2, edge 2, edge 1. Like that, and then what else do we have? The line. We just do that manually. So basically here vec2 line normal is line P1 minus line P0 probably. Yeah, P1 minus P0. And then line normal is vec2 of line normal at y, line normal at x minus Thank you very much for that, and that should be it. And then is overlapping for line and triangle. So we have our vec2 edge, triangle edge normals, triangle edge normals. Is get triangle edge normals with triangle. Like that. And then we don't really do a 4 here because we know exactly how many we have. So we just do vec get projection. Where is that? Oh, here. Okay, yeah, that's pretty straightforward. So we get a triangle and an edge normal, or what? What did I do there? I mean, I guess it works, but it's like so long ago that I can't remember almost what I did there. One second again, need to mute myself, allergies. The allergies are striking back. Alright, I mean, let's just do that, I guess. Again, we just do it normally like that for now, and then we think about that later. So that gives us back a projection, which is just a vec2. Okay, whatever. Vec2 get projection, where we give it a triangle and an edge normal, and then what we we project I guess we try to find the closest one to the okay, I mean, I guess. But then do we have yeah, we have a line as well. Okay. Get triangle on edge projection, I guess. Triangle and then vec2 edge. Or edge normal. Then we have a float. Min is our triangle P0 dot the edge normal. And then float max is min. And then min is min of min and max is max of max and projected. And now we do another float projection. I will try like do that with a 2. And then we return a vec 2 with min max. Then we do a get line on edge projection. Line P0, vec 2, line P1. And that's that, right? Yeah, it is that. That is the dot, yeah. Alright. Now what we do in the overlap check is we go through all the normals. So basically we do vec 2 we might actually optimize that a little bit. But okay. Actually, let's do that right away, that optimization, right? Because I don't think we need that. We can do it at the edge of that. So triangle 1 minus triangle 0. And then we flip that. Like that. Right. And we do the same here with P2 at P1. Now we do the same with P0 and P2. Let's do here edge 0, edge 1, and edge 2. And then we do the projection here. Which we do for all points, but okay. Vec 2, project that triangle points. And then the edge, normal. Do I not need to normalize that? Hold on. Is that not? I did not normalize that, okay. Fascinating. I guess it's not really needed. So we do that for the edge normal. Now we get the vec2 projected line point. Sorry. Get line on edge projection, line P0, line P1, edge normal. And then if projected that, projected that. Then we return false. And then we do the same here. So instead of that, we do this and this again. And we just do that. And then we do it here. One more time. And then we have this covered. And then we do a last one. Where we get the line normal. So we have that already here, right? So we don't need that up here, we have that down here. Not sure if we actually need it, but yeah, whatever. And then get projection. Return true. And then here triangle, 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 line normal, line normal. Did I really do that? I projected. Whatever. Don't question it. There was probably some reason for that. Okay. And I'm probably we do the same here. Just with the other triangle, right? Triangle 0, edge 0. I would assume. Exactly. Triangle 1, triangle 1, triangle 1. And then this is triangle 1p dot, 1 dot. And then probably that is like that. Triangle 1. Triangle 1, triangle 1. And then probably... Oh no, actually it's exactly the same thing. That's fascinating. Projected 0, projected 1. Let's do that. Projected 1, projected 1, projected 1, projected 1. Oh, projected 1, projected 1. Okay, and then we need to do that maybe up here as well. I think it's easier to read like that. Be right back. I think there was a weird sound. Alright, was no one at the door. I don't know what that was. Whatever. Projected 1. Projected 1, projected 1. Okay, I think that should cover all of that. We just need to do mmax. Well, with y. Could have maybe replaced that, but I was a little bit too afraid to do that. I could have probably done that though. And then mmin we replace with x. Again, Probably could have replaced that, but we have the time for that. Alright, so all of that should be there. This is garbage. Perfect. This we get rid of. And then that's about it, I think. If none of them hit, we return true. And I mean, that is probably it, right? So we should be able to go back here, and then wherever we had that two, we have that, which is a vec2, vec2, vec2. Yeah, I mean, probably fine. Maybe we just try and see how far we get with the compilation of the shader. We probably don't get far. If I have to guess, we probably fail right away. Because I'm pretty sure I forgot something somewhere. But let's try it and let's crash right away. What? No. I don't believe. What? I didn't do a single mistake? No, okay, no, actually no. That is not true, because we did not include it probably. Yeah, that looks better. I mean, better, unfortunately. So set 7 min can't use function syntax on variable. Oops. In 7. Maybe we do that. Min value. And then min value. Max value. Oh, fuck. God damn it. Oh, the allergies are killing me. Alright. So let's see if that is better. Well. Missed some semicolons here and there. Alright, and now we have a crash. Perfect. No matching overloaded function has sharp feature. Ah, is that because... Oh, we don't have that yet, or what? Oh, we don't have that, okay. Vec2 edge crossing from normer. Vec2 edge crossing to normer. And then we have to add that. That one is pretty straightforward. It's the float dot between those two normers. And then we do vec2 cross, which I hope it exists. Does Julian have that cross? Ah, but only between vec3 and vec... Yeah, because it's actually kinda ambiguous for a vec2, right? So what do we actually do there? So we probably just do that. Vec2 cross is x times edge crossing to normer y minus edge crossing from normer y times edge crossing to normer x. Oh wait, and then that returns a float, I guess. Yeah, that returns a float. And then we do an absolute of that. Cross is greater than epsilon. And our dot is greater than that pi, whatever. Do we have a pi already somewhere? No, right? So that might already help out quite a bit with that. Undeclared identifier 39. Oh yeah. Wait, what? Oh yeah. That and that. Edge crossing from in 78. Oh, where? Because we wanted here a vertex? No. Ah, here, that actually is vertices. Okay. Edge crossing from. And edge crossing to vertex. Like that. My nose is dying. Oh, okay. That is... Well, I mean, that doesn't mean that we are compiling, because now the only thing is that our debugger is not crashing anymore. Merging squares has intersection. Where did that come from? Oh, that was a member as well? Oh my god, okay. Which we kinda don't need. Oh, well, actually we don't need that. Okay, set to no overloading function found. Ah, because it's called set t is overlapping. Okay. Let's try that again. 177. Oh wait, I think we don't pass it in here. Disregarding that. A 186. Yeah, okay. Almost 100. Did I not save? Oh. Or I didn't fix the actual ones that it complained about. Unfortunate. Has face ambiguity. From two, and then, oh wait. Ah, got that has face. And min and max bounds, okay. Min bounds, max bounds. Why do we have that? Ah, because we've resolved the face sharp feature here. Okay. Alright, you are allowed to complain about that. Yeah, not even close. 221. Edge 0 from vertex. Edge 0 to vertex. Okay. I mean, maybe that's it already. Although, yeah, no, it's not. In out next line segment index. Min max bound outline segments in next line segment index here. Or next segment index, I guess. Yeah. Doesn't really matter in this case. So, do we have it running? No, we don't. 243. Min bounds, max bounds. Oh. Looks good. Is this readable in any way? No. But do we ever need to look at it again? Probably not, right? 294. It's not like we will have a bunch of bugs in here. I think we don't need that here, right? Oh, we do. Alright. If only my allergies wouldn't be so strong today. 175. This one doesn't return anything. Oh, you're right. I mean, probably here we return true, right? Resolve ambiguous case. How does that actually work? Oh, it's a void. Never mind. Not sure why it was a bool then. 294. Oh yeah. It works now, right? Almost. 311. Edge 0 from position. How does... Hold on, what? It's like in the airs of the... Oh, okay. Yeah, should be fine. I mean, we are almost at the end of that function. So, V20. Oh, where? Oh, that's fair. Did I cock that in the other one as well? No, I didn't. Alright. That was a long compilation, which might be a good sign. That looks fine. Do we have... I mean... We have something, but it's not entirely working. Oh my god, how long was my microphone muted? God damn it. Guess I was AFK and then didn't activate it. God damn it. Well, luckily I wrote down the list, so it's not really that big of a deal. Yeah, so this is the list that I will need to do to fix everything. We have to look at those first and then we can do those 3 afterwards. But I will now get some food and I will come after like a small break again. And we probably will look at the raycast first because that one is really annoying. That we are not hitting the point that I want to hit. I'm not sure. I will try to figure out what's the best way how to debug that because yeah, because it's not really that easy to debug that with RenderDoc unless we trigger it every frame, and then that's not really what we want. Hello, Mickey Maven. But I mean, it's already quite nice to do that, not gonna lie. It's already quite nice to paint like that, even though it's broken. That's pretty cool. So yeah, this will be the next couple of streams, probably fixing those kind of issues. But then we have like a terrain system which is pretty nice if that works. And adding different brushes is then really not that hard because I already have the code for most of them anyways in C++. So that shouldn't be... Okay, is that coincidence or is that not coincidence? Ah. Yeah, that is kind of sus. Okay. But yeah, as I said, I will get some food and then I will be back probably in an hour or so. So yeah, actually that would be the usual schedule, right? Like 7:30. So probably I will be back at 7:30. And then we will do a little bit more stream and hopefully fix a couple of issues that we have here and there. Yeah. Thank you for joining though, and sorry for having the microphone muted. I am not sure how that happened. Usually I try to take care of that, but yeah, I guess like as I went up and down and at the door and stuff like that, got kinda lost. So yeah, see you in an hour. Bye bye.